So, for I do research since 99, I think. I started in 99, of course. I'm a senior member at Hospitality, and I contribute to testing guide with some chapter. I did a Flash security research and developed the Swift intruder testing tool for finding bugs, DOM Xss in Flash in ActionScript at runtime. And in the spare time, I work in managed security as the CTO, and I like everything I do for research and for work. These are yes. These are my blogs. My Twitter name is Wisek. So join follow me. What are we talking about today? DOM Xss. We'll talk about what are sources and what are scenes in JavaScript. We will see some interesting example, and we will see a new tool I released just a few days ago, whose name is Dominator, which is we can help finding cross-scripting at runtime. So what is DOM Xss is the first formalization of this kind of vulnerability and attack was done by Amit Klein. And this is the link, the URL where you can find. And there is not so much literature, at least in terms of structured literature, just some research, some spotting research. So it's not easy to find good information, very good information. There was a very interesting blog post by Yuri Sigal from Watchfire, formerly Watchfire actually, now it's IBM, and it was a very interesting example on how in some cases it's possible to control the flow of a JavaScript from an attacker window, of a JavaScript being victimized from an attacker. And in 2K8, I presented with Alex Kuza a research which is partially covered also here. Now, what's now? Now there is the OS page about the XSS, and I, just for this project, I decided to set up a project in Google Code, which is actually a wiki, and it's the DOM Xss wiki. I used to understand, I used to public what I researched about how browsers treat special characters without, when the characters are not decoded. So vanilla, we take from a source a string, and for example on IE the angular parentheses in the query string are not encoded, so we can actually use them to perform an attack or DOM Xss attack. But for example on Firefox they are encoded, so it's not possible to use them if they are not decoded, voluntarily decoded. So what's what's a source? Source is the input data that can be actually controlled by an attacker, by an untrusted source. And then there are the scenes, which are what's called potentially dangerous functions. We will see what kind of exploitation can be and substitution of data in order to reach data validation or auto encoding. Okay, so untrusted sources can go directly to a potentially dangerous function, or can be filtered by something and then passed to things. So the question mark there is we don't know actually if the data is filtered in a good way or it's simply a bad filter. So what are input sources? Mostly everything that can be reached from JavaScript. In this case, anything that can be reached by JavaScript and the attacker can control. So the referrer, everything in the URL, the query string, the hash, the window name. We know that, for example, we can target a link to another window, and we can see, we can tell what will be the window name where the link will open. So the attacker can actually control the name of the target window. Something else. Now in probably a couple of years, maybe 1 year, there is the post message function, which is an event, which triggers an event, and the victim window, if the victim window, for example, listen to a message, a post message event, the source in this case will be the message, which is the argument, dot data. So that the dot data is the controlled data. Then there is something else for dialog arguments with the show method dialog and so on. Then those were the direct sources. Then there are intermediate sources, which can be, for example, something like storage. No, in a page, the JavaScript stores some data, which is actually untrusted data, and then use that after in some other page. So there is no direct connection, but there is actually an intermediate source. Same for input values, for example. They go to the server and then they go back populating or instantiating a value in an input box or something like that, and then is taken from the JavaScript to perform some operation. Also, in these cases, there is also another thing that can be done. Sometimes probably you will find, we will see an attack, you will find that the input, the data you insert in an input box is actually used for a sink, in a sink. And one can ask, okay, but how can exploit that? We know, everyone knows clickjacking. There is a drag and drop feature in HTML5, and Rosario will talk about that this afternoon, right? And so it's possible to abuse that feature of drag and drop in order to trigger the attack. Then there are cookies, of course, and the response of some HTTP requests. Okay, classic things. Insert tag directly, for example, inner HTML, outer HTML, document write, and so on. Then everything that use some data to interpret JavaScript, and it's eval, SCS3 function, and set timeout. You know that set timeout can get the argument as a string or as a function, an anonymous function or a function pointer. Also, location assignment, the calling of replace, and so on. less classic things. Yeah, because not all the things must result in JavaScript execution. The problem with the security is that, for example, in server-side attacks, you probably rarely get command execution on the server. You will find some SQL injection, XSS, privilege escalation, and so on. So JavaScript execution is just like command execution on the server side, right? So in this case, in the case of client-side exploitation, it depends on what can you achieve actually. So in this case, you can maybe modify the DOM with some data, with some source, or HTML objects, or you can get some cookie or insert. So inject cookies and performing session fixation, and perform directory traversal on XML HTTP request in order to control where the data is actually going, and maybe after that, depending on the logic of the application, you will get some data leakage, for example. Then there is cross-origin request. So in the new browsers, it's possible to request using XML HTTP request to ask for data originating from other hosts than the one hosting up the actual JavaScript. And then also, client-side HTTP parameter pollution, we will see an example. In this case, we can, for example, modify DOM or HTML object. How? Let's suppose that, for example, the key element of the document object can be controlled by the attacker. Of course, in this case, it could be, I don't know, cookie. Okay? The source value is cookie, it becomes document.cookie. It's not, for example, what the developer was expecting, maybe some name of some custom variable. Okay? Also, this is worse, and the second one is worse, window, because actually you control the name of the key and the value of the key. In this case, what do you think about it? Could be, the key could be location, and the value could be JavaScript, columns, and so on. In that case, you have actually JavaScript execution. Also, there could be something like this. A native object with some default value that can be controlled in the key and in the value. The developer was thinking about only default x and default y, okay, default y, sorry, and instead it's possible also to modify URL. This is some sort of security through obscurity. In a lot of data, the developer will think, okay, but who cares? Probably no one will look into this code. Then, for example, insert new cookies by using the setting of the instantiation of a new cookie. Think about that. Document.cookie equals some constant concatenated with an unescaped value. On Firefox, I don't know if you knew, but it's not news, this one. If you can inject a new line, Firefox will create a new cookie. So this will result into cookie name equals a pound, and a new cookie equals 1, 2, 3, 4. CSS injection. Sometimes it's not possible to inject direct JavaScript, or maybe in the case of, for example, of Firefox, it's not possible to execute JavaScript in the context of CSS parser. It's no more, at least. So with CSS injection can be done some interesting thing. We will see. I have an example. And also, for example, injection, controlling the source of an image. In these cases, of course, it depends on the brain of the tester or the attacker. No, it's very important to understand the logic of what's going on. No? For example, consider checks for anti-cross-site forgery by looking at the referrer. No? In that case, it's possible to force the referrer if you control an image tag in the victimhost. Of course, in this case, it would be a GET request, of course, but sometimes, often, a GET and POST are switchable. No? CSS, I presented this 3 years ago, and also Söderkatt did the same research independently, and we released it in the same period. And it's possible, actually, if you can control a CSS to get sensitive values without executing JavaScript. Oh, let's see. Okay. So there is a frame controlled by a page controlled by an attacker, which injects a CSS in a frame, in a page, victim page, where there is the possibility of CSS injection. What happens here is that getting on the other iframe the value of a hidden value inside the victim iframe, and that's the value. So in every second, the page is reloaded, and using something like the history hack in web, for stealing history, user history, it's possible to get the value of an hidden frame. How it works? Using attribute selector, SCS3 attribute selector, it controls if, and since it's possible to use attribute substring matching, it's possible to understand if a value in an attribute on some tag begins with A, for example. If it begins with A, it will load a background image, for example, which will be sent to the attacker. So the attacker knows that the attribute value begins with A. Then the attacker creates a new CSS on the fly, looking for what's the next character, and so on until it will be equal. And that will tell, by using a background image that will tell the attacker is finished, the research is finished, and that is the value. So, for example, for token, anti-site request forgery token, if there is a CSS injection, you can actually get, as an attacker, that value. Cross-origin request. Finally, we achieved a new feature which can be actually abused and is being abused, which is the cross-origin request, which is now available on every browser, almost, I think, but yeah, it's possible actually to use an HTTP XML HTTP request to ask for external responses. Just the attacker needs to add this header to the response, and the browser will read the response and do something. Okay, this code is actually is like the Facebook issue on iPhone on the mobile page, mobile host. It was controlled. It could be controlled by using an URL, a full URL, by an external attacker. And of course, it was possible to load a page arriving from another host, external host, and in that case it was used as inner HTML, so it was actually exploitable with direct JavaScript HTML injection. For example, suppose then that Facebook adds a filter there. So, because they actually want to load asynchronous pages from user profiles, no? So, let's add a filter that filters out if two slashes, forward slashes, are, or if HTTP, no, is at the beginning. So the attacker can try to understand if the browser can load external requests in some way. And we have those guys that did this research, actually. Understand how browsers interpret strange patterns in URLs. What's a strange pattern? For example, this HTTP columns backslash backslash backslash. Okay. In this case, we know that Chrome 9, Chrome 11, Safari 5, Express 6, 7, 8, Android resolve that URL as an external host. Okay. Same from this one, for example, slash slash. So you don't need HTTP and you don't need the columns. And but you can go to that host, to that page, and you will see what's going on for each browser. This is interesting because you need to know how a browser behaves before applying a filter, no? And the attacker knows because he's interested in that, no? So let's talk now about filters. Classics filters: escape, encode URI component, encode URI, or URL. Sometimes all those filters, all those functions, are not always used in the right context. For example, encode URL does not encode the ampersand, and so on. The advanced filtering, it's about replace, match for conditions, for present condition, and so on. In this case, I did this simple JavaScript snippet of code snippet to understand where escape and code URI and code URI component, where they behaves differently. So in that case, I know if a filter is being applied in the wrong context. Okay. This is the decoding difference. So, for example, let's take this regex. You can understand where it comes from, no? BBC. This controls if the source of a script belongs to the BBC domain, but it's wrong, of course. In this case, there is no check for the beginning of the line, the beginning of the position. So it's bypassable, and this is actually there. This one uses a white list of tags, bold and italics, which is filtered at client side, and that one is the regex. This is a bit more complicated, but the problem is mostly in the modifier. That's case insensitive and global. It misses just one thing, which is the new line, the multi-line. So, with a new line, that regex won't match, and we will pass all the string to the HTML, to the inner HTML. So it's important to understand what's going on by understanding the filters, no? That's a new thing that I found 3-4 days ago. I told you before that a new line in Firefox will generate a new cookie, no? I saw that it's possible to use a special character like that one. I see with that point, with that spot on the top, which has this encoding 010A, and since 0A is a new line, probably Firefox just doesn't see the multi-byte. It does see ASCII, and this will bypass that filter because the filter looks for a slash for new line or carriage return, and not that character. So that one understands multi-byte. The Firefox cookie doesn't understand multi-bytes. This is interesting because this can be used to exploit several things. What does this one? It splits tries to parse and find the cookies, no? Find the cookie value and get the cookie name and get the cookie value. Splits with semicolons, and then tries to find the name of the cookie. No? In this case, there's a problem because, for example, if somewhere document cookie is written using a source, for example, document referrer, and somewhere else there is an evolve get cookie user history, okay, using that previous function. What happens if I set the document referrer like this? You see, user history equals alert 1. So it creates this cookie, ref equals all this stuff, and then the function, the previous function, looks for user hist, but not in the right way, because it doesn't look at the space. You know that cookie are semicolon space cookie name, and in this case I inject a fake cookie because of a wrong parser. Yeah, and that's the recursion. Yeah, it's a joke I actually was told about, but it's about recursion. Yeah, well, it was about oven. I know you like baking, so I put an oven in an oven, so you can bake while baking. The flow control check. For example, for opener object, parent object, top, and so on, and checks on those elements can be for the existence or disequality of that kind of some value can be fooled by an attacker window, because an iframe name can be named, in this case, frame message of the parent window, which is controlled by the attacker, and from the victim iframe asks for what he thinks is just an object, or a string in this case, but is actually the name of an iframe, and it's accessible. It will return a window object which is actually cannot access to anything else. Okay, it just returns a window object, but this won't generate any kind of exception. So if the attacker adds an iframe whose name is frame message, this will pass internally here, and this kind of problematic issue, this vulnerability, will be triggered. So it's exploitable. Someone can say, no, it's not exploitable because the attacker must control a name of a string, a content of a string, which is impossible because of same origin policy. In this case, it's not true. It's exploitable. And also, this kind of flow control, well, these are classic time of check to time of use. It's a race condition. If name equals or match something which is as destructor, so actually nothing, okay, it's just an assignment, so it can be valued. Actually is the attacker can try to change in a very fast way the name in order to get those match be satisfied, and then change after that the value of the name and get. So yeah, browser countermeasures, content security policy, which is actually not used. There is just one side that uses and uses bad. And what's the methodology? So the methodology is use these regex to find the sources, use these regex to find the sinks, and then follow the flow of these. Yeah, I know. It's not that easy. Also, you can find compressed code, obfuscated code, slacker said code, no? It's difficult because in these cases, those regex won't work, of course, no? Yeah, okay, so someone can try to use to create a static analyzer. And the static analyzer is very good, but doesn't find everything. A lot of false positive, a lot of false negatives. Because, for example, of all this, one can try to use script injection, dropping, sources, and sync. It's very good, but it misses the flow. I decided to try to create a solution with a bit of research by using runtime analysis with dynamic tenting and script injection in order to have the flow and control source and sinks. What is? Let's see. It's a modification of SpiderMonkey in order to add the tainting flag to strings, and so SpiderMonkey is the JavaScript engine in C++, written in C++. And I modified also some point in Firefox. So I had to recompile everything, and then I created an extension for logging the events. How it works, it's kind of complex, but not that complex. The most interesting thing is that Firefox is just Firefox with 3 new static function, string.newTainted, string.untaint to remove the flag, string.getInfoTaint, and then I used the debugger, but that is another story. And those 3 new functions, using an injection of a script which drops location, document write, and so on, is what needs to create a control, a new tool, this new tool, which actually will result for the user in a user interface with a log monitor and with some feature that will tell you when a source is used, and then follows the flow automatically, and then will tell you when the sync is used that is actually controlled, can be actually controlled by the attack, by an external source. And I can show you. There you go. So, I'll show you first of all what happens. For example, I try to get location hash, I escape it, then I add it to, I concatenate something, and I remove the parent. Then I execute it. The result will be shown here. So what happens to the log, in the log? It says that inner HTML was performed using something that is controllable, the location hash, of course, and in fact tells us that the source is location hash. By clicking here, we have the operation that have been performed before becoming the argument of the inner HTML of a div. So why is in this warning tab? because it's not actually exploitable, because there is an escape. The escape escapes everything, so it's impossible to inject the quotes or angular parentheses and so on. But maybe then somewhere is unescaped. And there you go, that we have it in the alert window, in the alert panel, because it controls how many times in sequence is escaped and unescaped, and so on. In this way, we can understand if the sync is exploitable or not, and where, because we know what's looking for. Okay, so let's go to AOL, and let's see what happens. We see here what's looking for. Here it splits the host name for point. Search for point splits the host name. So we don't. Here it looks if the host name is localhost. That is JavaScript actually running. Okay. Then tests for here tests if an IP. Here, and that's interesting, is looking for these parameters, ATWAC equals. Where? In the location href object. So we try to add it. Voila! There you go. Here we can see that the seventh operation, which is in fact this one actually, and this is the flow chronologically, looks for ATWAC. Then you can see here 1, 2, 3, which is this, no? And then tries to replace the ampersand everything else to nothing, which is also not global, and then splits trying to find a pipe or a semicolon, and then uses it 1, 2, 3. There you go. You can see the concatenation 1, 2, 3. There is no escaping, so it's actually exploitable. Where is exploitable? Because is exploitable, go to DOM Xss wiki. I've almost finished. Okay, it's not working, but go to this and then find that Internet Explorer or Chrome. No, maybe, yeah, Internet Explorer. But in this case also, we can see here that it's not looking for a particular point. So we can actually also add it after the bound. So it doesn't go to the server. In fact, is actually again. And we here know that this can be controlled. No, it's not going. Ah, there it is. And we see that. Oh no. Location. Href. There you go. Explorer doesn't encode angular parentheses and a lot of characters in the hash, in the search, and in the path name. So we can try on IE to ingest something. Okay. see. Then we escape, we close the script, and then we open another script, and then we close the script. And let's try. Wow. Okay. Just to this is the JavaScript you should watch by hand. Okay. Just the last one, which is interesting. I just borrow. Try to type in the box. Try to type in the box. There's another issue. We can here. I will show you just CB, which is the callback, alert, blah. Because you can learn it by using it. Okay. So if there are any questions.
Any questions?
Okay. Thank you.